Okay, for today, I'm walking you through what are called the application problems. These are the ones that are word problems that involve the quadratic formula. So first thing I want you to all do is make sure your calculator is working. Would you please type in y equals 2x and hit enter? And I guarantee you, after you hit graph, a lot of you aren't going to be able to see your graph. I'm going to suggest one quick fix is zoom 6. If you do zoom 6 and you still can't see your graph, then would you please raise your hand and I will come and help you. I'm going to pause for a second. We're just trying to make sure the calculator's graphing feature is working. Graph y equals 2x. Compare it to the kid next to you. Zoom 6 will fix a lot of the problems. Okay. If your calculator at any point gets stuck, first ask the kid next to you. Then if both of you are like, I don't know how to fix that, then raise your hand. There's only one of me, and I'm not going to be able to get to like 6 questions at once. All right. Now, I want to graph a quadratic. So what's the simplest quadratic of all of them? X, that's the x, and then squared. I'm going to move this over so I can see my squared key is right there. Y equals x squared. Go ahead and graph that. Okay, does that look like the graph of a ball thrown in the air? No. We did this kind of thing before. What's supposed to be different here? Yes. It's supposed to be negative. You are correct. So everybody go to the y equals. And we're going to, in case you didn't know this, there's an insert key. You don't have to retype everything. Insert is right above delete. See right above DEL there's insert. Insert a negative. Notice the negative key is not a minus key. I've got it red up here now. That key is the negative key. I inserted a negative. INS is right above delete. It's really handy when you don't have to retype everything. Okay. Now I'm going to hit graph again. And now at least it's an upside down parabola. That looks a little more like the flight of a ball. Okay, but it's a ball that didn't actually go up in the air at all. You know what I mean? So let's go. Y equals negative, and I'm going to move over and I'm going to insert something else. Negative 4.9. Does anybody remember what that is? That's the beginning of the gravitational constant. Negative 4.9 x squared, and then arrow all the way over, and then say plus, I'm going to say 5x, and that, by the way, is the velocity. The person was throwing the ball at 5 meters per second. Why meters? Because the negative 4.9 is in meters, so I have to use the velocity in meters. And what if I'm throwing it from... I'm throwing it from over my head, and if you can reach to like 2 meters high, then you could be releasing the ball at a starting height of 2 meters. So I'm going to put plus 2. Do you get where I've got those things? It has a speed of 5. It has a starting height of 2. Think of it this way. At time 0, that would be x is 0. Do you get if I made x 0? These two parts would disappear, and I just have y equals 2. At time 0, the height is 2. Okay. All right, so there. That is a quadratic. Now, could a person throw it faster than 5 meters per second? Sure. I'm going to see if you learned anything about insert. Try to make that 15 meters per second. Instead of 5, make it 15. And don't retype everything. Get right over where you'd like to have the 1. I want the 1 there, and then I want everything else to move over. So I'm going to go second insert 4. Bad idea. 1. There we go. There. Now the ball will go up higher than it would have. Okay. Now next I want to graph this thing. So everybody hit graph. And you might be like, wait a minute, I don't see it. Sometimes it just graphs it and you can't see it at all. You go into window and you have to move up to where you can see it. Now, do you get right now I can't see the top? Hit the window button I'm going to leave it red for a second so you can see where it is. That window button. And you want it to go higher. Is higher an X thing or a Y thing? Y. Y max. Very good. So the Y max, I want it to be bigger, so I want it to go to a maximum of, let's say, 20 instead of 10. Now I'm going to hit graph again and see if that did it. Yay, it did it. Okay. Now, here's the 4 things we can ask you. And I'm going to show you how to find. Number 1, do you see on the graph the spot where the ball reached its maximum, like its highest height? Do you see that? Nope. I'm just asking, can you see the spot where it was at its highest? Right there. And one of the things we really got to get straight is what are the X and the Y axis labels? So make sure you pay attention to this. This is time, and this is height. So every dot on here, or here, or here, or here, or here, or here, that is a height and a time. It's got an X and a Y coordinate, right? So it's got a time and a height. All right. Then, would everybody please follow this logic? Everybody go to second calculate. It's right above trace. If you were designing this menu, this is again right above trace, second calculate. If you were designing this menu, wouldn't you put the thing that you would want people to use the most at the top of the menu? Yes, and we will use calculate a value. So let's try that once. Just hit enter because we're on the one already. And now, what's different about my screen? It has an X equals blinking there. It's saying, what do you want X to equal? Well, what is X? Is it like chickens? Is X inches? What is X? Remember what X is? Time. So at time 1, we could figure out where the ball is at 1 second. Everybody hit a 1, hit enter. Do you see how that could be handy on a test if they said, where is the ball at time 1 or at time 2? I just hit second calculate value. All right, everybody check and see if you really understood that. I want to know where is the ball at time 1.7. 1.7 seconds into its path. Where would the ball be? Is that an answer or a question? Question, go ahead. Yes, but when you put in the gravitational constant, you divide it by 2. It's g over 2 at the beginning of this equation. So I'm glad you noticed that. That's good. All right. How do I do that? Second, calculate value 1.7. And it should have come out to, it's hard to read, is it 13.3? All right, 13.3 dogs. I'm obviously being annoying here. I'm trying to remind you, you've got to label your answers. If you just write 13.3 on your test, it will be wrong. 13.3 what? Inches, seconds, feet, meters, time? What is the 13.3? That's meters. Okay. All right. Next, we now know how to tell it a time. How do we tell it a height? This one's kind of outside the box, but go back to the y equals, because do you get that y is the height? Isn't y the height? X is the time and y is the height. So if I say y equals 4, do you get that that's going to be height equals 4? So put in a new line at y equals 4 and hit graph. Do you get, and yours might not be fancy and in color, but do you get that that line we just drew is where the ball is intersecting with a height of 4? Does it look to you like the ball ever made it to 4 feet? Or meters? 4 meters? Yeah. And in fact, didn't it make it once on the way up and then once on the way back down? All right. So how do we figure out exactly when it got to 4 meters? I know its y value is 4. What I want to know is what was the x value. Yes, what do you think we're going to do? You really want to use that trace button, don't you? All right, so if you hit trace, there's nothing wrong with this. I can get close, but it won't give you exactly where did it touch that line. So let me teach you more advanced. I know you're like, but mine's really close. Okay, really close is not good enough in this. We need exactly where did those touch. So here's where you do it. Second, calculate. Remember how last time we used value here? Somebody smart figure out what we're going to do now. We are not going to do the 0. Nope, that was not a 0. That was an intersect. Very good. That's the 5th option, intersect. And it seems like it just jumped right to the answer. It did not. You need to arrow around using the left and right arrows until you're really close to the right spot, and you won't be there until you've hit enter 3 times. It's asking you questions in the lower left. It says first curve. Yeah, you're on the first curve. Second curve, yeah, it jumped to the other line. How do you even tell that it did jump to the other line? And last it says, guess? That means you get really close. Now, I just got it really close in the first place, and then the trick is you just hit enter, enter, enter. Okay, so you hit enter 3 times, and it finally says intersection. 0.1, I'm going to round it, 0.14, and y equals 4. Notice, I expected it to be y equals 4. The thing I didn't know was what time. Do you get it was at 0.14 seconds that the ball went across the 4 meter mark. And now, everybody else, all of you guys, try to get the answer for when's the second time that it hit 4 meters. Hint, use the same feature except go over to the other spot where they cross and hit enter, enter, enter over there. I may not have given you enough here, but I think you can do it. I'm going to pause and see how many of you can figure this out. You're calculating the second time when the ball met 4 meters. Okay, I didn't get to everybody, but if you got lost, here's what you do. Second, calculate, intersect, and then here's the key. You got to move over right by where they intersect. The calculator is not smart enough to know which one you want. I mean, what is it, psychic? It can't know which of the 2 intersection spots you want. So you got to go over next to it, and then, am I on the first curve? Here, I'll show you a little better. Am I on the first curve? Yeah. Am I on the second curve? Yeah. Am I really close? Like, guess where it is? And then you hit enter the 3rd time, and it says intersection 2.92. So there's 2.9 chickens. No, 2.9 what? Seconds. And then what's the y again? The height. Okay, so this is all about understanding what this means. That's at 2.9 seconds, you were at a height of 4 meters. All right, what if the question said, when did the ball hit the ground? Hint, the height isn't 4 meters anymore then. When did the ball hit the ground? Hint, its height isn't 4 when it hits the ground. I'm going to pause for a second and see if you can figure that out. Okay, I gave you a pretty heavy hint when I said the height isn't 4 anymore. We got to get this y equals 4 out of there and make it a y equals 0. You didn't have to do it that way, but I think it's the easiest way. Make a y equals 0 line, hit graph. Now, instead of seeing when the ball was at 4, the red line will be where was the ball at 0. And the first one isn't really logical because the first one is the ball didn't actually start on the ground. We started throwing it from 2 meters up. Okay, so when we let go of the ball, it never hit the ground to start with. It only hits the ground over here. So that one is the important one. Second, calculate. Second, let me get that out of here. The intersect spot between the blue line and the red line. Do I have to get exactly perfectly on it? Nope, just get close. Enter, enter, enter. Did you get if I round it, 3.2 seconds? Raise your hand if you said 3.2 seconds. Awesome. Do you get, if a person actually went to the parking lot and threw a ball up in the air and the ball stayed up for 3.2 seconds, then this would be the right equation for it. Do you get what I'm saying? Could you time that right so that you throw the ball up and it, I mean, could you make it perfect? Well, it'd take you a lot of tries, but eventually you could get it. And then you would know that the speed in the upward direction would have been 15 meters per second, and you would have started release height 2 meters. It's just over your head. So it's like you're throwing it up like this. Okay, and if it stays up there for exactly what time? Well, I'm going to go back to my graph again. And, oh, it's gone now. I did second calculate intersect to get that. All right. There's only one more thing that I haven't taught you how to do yet. That's fine. What's the highest that the ball ever went? Guess what menu it's on? Second calculate, just like all the other ones. Which of these seems like it's going to tell you the highest the ball ever went? Maximum is correct. Everybody go to maximum. And now this one's different. It's going to ask you different questions. Let me help you with it. Everybody do this with me. Second calculate maximum. Left bound. That means get to the left and make a boundary on the left side of the maximum. I know and you know that there's only one maximum up here. Computers right now are still, thankfully, not as smart as humans. Otherwise, this thing would already know that there's only one maximum. That would be logical, and it would already told it to you. Okay, but we got to just be happy that computers haven't taken over the earth yet. So it's to the left of the maximum. Cool. I hit enter. Puts in a little dotted line on mine. For yours, it might just put in that little wedge that's saying, that's the left side. Now we got to get to the right side of it. And it says right boundary. As long as you are to the right of the maximum, you hit enter. And what it's trying to say is, oh, so you want the maximum that's between there and there. And then the last thing is always guess. And that's saying, kind of show me where this spot is. And it's kind of right there. Why can't I just use trace and get that spot with trace? Because it's not accurate. Trace will get you close, but it isn't promised to be the very, very top. Whereas this function gets you the very, very top exact, and it might have only been off by 100th, but now it's super exact. And what is this? Even more important than normal is that 1.5 chickens? Is it 1.5 inches? Is it 1.5 meters? What is that 1.5? Seconds. That's when the ball did what? Reached its highest. Okay, so at 1.5 seconds, it was at its highest height, which was 13 inches. No. Which was 13 miles. No. Which was 13 chickens. No. Which was 13.5 meters. Okay. Now, to see if you could answer the test question, I'm going to give you 4 questions we could ask you about a situation, and you and your partner are going to try to answer these 4 questions. All right. I'm going to make the equation slightly different, too, because otherwise you already know all the high spots of this one, the important spots. So go back to your y equals, and here's the first thing I'll tell you. The kid's a baseball player, so he's really, really strong, throws it at 20 meters per second. Throw it 20 meters per second. He's pretty strong, but he's not that tall, so he releases at 1.5 is where he's like his release height, his initial height, his starting height. And here's my question. What's the highest the ball went? Number 2, when did it get there? Number 3, where was the ball at 1 second. Number 4, when did the ball cross 5 meters? Hint, it does it 2 times. So there's 2 answers for question 4. Questions? Yes? Meters per second is MPS. It says MPS, that's meters per second. And so you should use the 4.9 at the front of the equation. The velocity is in meters per second. That's the middle of the equation. The starting height, 1.5, that's the end of the equation. All right, I'm going to pause for a second while you try to answer these. I will show you how, but first, you should be able to do it. You'll learn a lot more if you try this yourself. And yes, he's throwing it straight up. Just keep your life simple. We'll just keep this all vertical. Okay, so I'll walk you through what I did. First of all, you're on Earth, so it's negative 4.9 x squared. We leave that alone. This 15 changes to a 20. Then that starting height of 2 changes to a 1.5. Now, how about that other height? Last time I had a 0 in there. That's when I wanted to hit the ball hitting a height of 0. This time I wanted the ball to hit a height of 5 meters, so I changed that to a 5. All right, then I'm going to go out to my my graph, and I'll see if I can see the top of my graph. Oh, I can't see the top of my graph. This is a part where you'd have to know that I got to go to Window, and I got to go higher. Is that X or Y? That's the Y. And max sounds like highest, so yeah, that's it. I'm going to go to 25, and maybe that'll be high enough. I don't know until I check. I hit graph. Yay, I can see the highest height. Okay, now, the highest the ball went is called the maximum. It's right there. How do I get that? Second, calculate maximum. Goes like this. Maximum is the 4th one, so I hit 4. And then it wants me to have a left boundary. I get right up kind of close to it and say left of it. Now I'm to the right of it. Do you have to be like perfectly centered? No. Just go up to the top when it says guess. Then I hit enter. And it says maximum. 2.04. I could say you could round that to 2 seconds. Add 2 seconds. It was at 21.9 meters. Raise your hand if you had 21.9. Okay, awesome. Then, where was the ball at 1 second? Well, it wasn't that high. Can I just arrow it down until I find 1 second? You can get close. Look, I'm looking at my screen. I can see that I'm at 1.6 seconds, 1.5 seconds. And I can try to do it this way. It's a real pain, though. The easy way? Second, calculate a value of x equals 1. That's time 1. And poof, it just jumps right to it, and I got 16.6. Raise your hand if you had 16.6. And last but not least is, when did the ball cross 5 meters? There's 2 answers. I go second, calculate intersect. And then my advice to you is, it's going to ask you 3 questions. Am I on the first line? Am I on the second line? And guess. If you just get really close and hit enter, 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 it jumps to the right spot. And that is 0.1, I think that's 8. That would mean 0.18 seconds after you let it go, it crosses 5 meters. And then the other time, second, calculate, intersect, get really close to that. And as long as I'm actually closer to that than I am to the other one, it'll jump to it. That's close enough, actually. Do. And there we go. I'm going to round that to 3.9 seconds. It was at 5 meters. So it is there twice, once on the way up, once on the way down. How many of you feel like you could do this again? All right. That's what you'll have to do on the test. Covered it all. Now we're going to practice it. Now I figured a way to make your homework smaller, because this took a lot of time. You don't have that much time left. There's not a ton of questions, but each question has a ton of little subparts. So what I'm going to do is assign you problems 1 and 2, and since it's a Schoology quiz, I'm going to tell you the answers for problem 3 and 4. Now, if you want to go through and like actually try them, totally cool, but I'm kind of like telling you to skip a problem on a worksheet. I'm telling you the answer for this so that you can save yourself some time. All right, so if you want, here are the answers, and I am not certain that I'm going to be able, that my colleagues would want me to record these answers, because some of them take these and assign all of them and may not want these answers out there. So I'm going to stop the video at this point, but I'm assigning you all but the last 2 questions on the Schoology quiz, and that's all I got for